Okay, we're rolling into week 7, and so we're going to do the presentation lecture for Masters of Healthcare Administration 575. We're going to review some analytical tools, the first being the failure mode effect analysis. I do know there's information also in your textbook. Um, just to do a high overview, though, it is a proactive review, and it's to prevent an issue. It's to strengthen a process that you feel like may be problematic, could be problematic. So you're trying to predict what could go wrong, predict what a failure could be, what could happen, what would be the consequences, and then what's your game plan, what's your action steps to prevent that from occurring. I know with the Joint Commission surveys, we have to do a failure mode effect analysis at minimum every 18 months. So again, it is a regulatory component that they are looking that you are fulfilling these. This is something also that's not just a healthcare specific tool. It can be done in industry as well. So it does have broad use, and there's a lot of information out there to help you with actually doing that failure mode effect analysis. The root cause analysis, you may also see serious event analysis. I know within HCA, which is Hospital Corporation of America, we use both. So we've been going down that pathway. It's a problem-solving tools, and it does have many steps to it. There's software also that can help to populate your information. It is retrospective. It's a deep dive following an event. So there has been a sentinel event that has occurred. You really have to focus, on the why. The why question is critical. You can't just simply go in there and ask one why. They recommend you do a minimum of 5 times where you drill down to get to the true root causes of what caused the event. And oftentimes, if you do this series of questions of why, you'll ask the first question, you'll get a simple answer, and if you just keep drilling down, peeling back the layers, you will find out the true the cause of the event, and oftentimes it may not be what you would really predict before you would do the RCA or the SCA. So again, it really helps to give you a better picture. It's very detailed. There are times when we do RCAs within the healthcare world, and we are talking huge binders of information from where we're doing each step of the process, then our action plan that correlates to what we find out, and then what we submit to the Joint Commission. When we do an RCA, should we have one with our accrediting body, we do actually do a WebEx. You can go on site to Chicago to the Joint Commission to present what details you found out, and then to submit your action plan for approval. But we usually have been doing that through WebEx, and that has been equally as effective. Analytic tools continuing. An intensive analysis, it also is a retrospective review, but it's not as intense as you think about the root cause analysis for a sentinel event. This is a situation where there's still been an event, but maybe it's a good catch. Maybe it's a near miss. So you still want to go back. You want to look at what happened. Where do you have weak links? Where do you have opportunities? Where do you need to create action steps and put those into place? So it has a good purpose. It's just not as intense as a true full-blown root cause analysis. So back to that failure mode effect analysis, the Joint Commission, also the Institute for Healthcare Improvement, they do have excellent resources. They also do for the root cause analysis as well. But the one thing with the failure mode effect analysis tools, you can add up a kind of a point value. So they have these columns, and as you can see at the top, you can list your failures, and you may want to do that with a brainstorming, like a fishbone diagram, which we'll talk about in a moment, to come up with your list of potential failures. And then you're going to want to evaluate what is the mode of that failure. What is the category of which it falls under. So maybe it's equipment, maybe it's, personnel, human resources. So it kind of gives you a fluid idea of where to go. Then you can rate it. So you're going to rate 1 to 10, how problematic, how severe would it be? 1 to 10, the occurrence of it happening. Is that a high probability, rated a 10, low probability, maybe a 1 or 2? How easily is it going to be detected? So again, you're going to rate the same way, 1 to 10. And then you're going to go and multiply your severity, your occurrence, and then your detection to come out and find out your top maybe 3 areas you really want to focus on in creating potential solutions and monitoring in this failure mode effect analysis. So again, it is a deep dive. It is, though, proactive, so you're wanting to prevent a situation from occurring, but this gives you a tool. I've also seen in many slides when we've done a PowerPoint to go through what we found out from doing this failure mode effect analysis tools. It follows quite a bit the DIAMAC, which is what we use with the Lean Six Sigma process, and we talked about that last week. So you do start seeing some repetition and some crossover between these different analytical tools within the quality world. This is a listing. We're going to hit on some of these. I'm not going to go into detail about the dashboards because we did talk about that last week, but we are going to look at examples of these other tools. Flowchart, you may also hear it a process flow diagram. Both are fine. You're really looking at just separate steps of what happens, and it's in sequence. You're wanting to see as far as inputs, outputs, decisions, are people involved, is there time involved, the steps, how are you measuring it. So you're really wanting to pick up the flow of how a process or a situation occurs in your organization. So there's a lot of examples out there. It doesn't have to just be in healthcare. You can use this anywhere. So we're going to look at an example. Before we get to the example, though, one thing I think is good to know, there are certain symbols that correlate in a flowchart that mean certain things, and this is universal. So if truly you're doing the correct flowchart and using the correct symbols that are universally known, you're going to see the example, the oval at the very top column. It indicates a start, and then it also indicates an end. And it just gives you that overall presentation. You can see arrows. They've got the kind of slanted rectangle that's input output. A straight up rectangle is a process. And then if you see a triangle, that means that there's a decision that has to be made in that segment of the flow chart. So what does this look like? Here we go. This is an example I just pulled off Mind Tools, and it's about an incoming phone call. So this is, fairly simple, fairly straight up. These flowcharts can be very, very in the weeds, very long, very drawn out, or they can be very simplistic. So this one is really more simplistic, but you have your start. So the first step's answering the phone. They are, asking a question, how can we help you? And then you'll see that the arrow flows both to the right and to the left. So depending on how they answer the question, it's going to go one way or the other. So if you go straight down, it's going to go into the customer service. What's the problem? Is it a billing issue? Is it a shipping issue? And then what problems are there with the product? So you just keep drilling down. So it gives you a nice visual of what to do. These are also sometimes called algorithms. We see these oftentimes with CMS, which is Centers for Medicaid and Medicare Services, and the Joint Commission, for specifications and some of the core measures that we're looking at, and it just kind of helps you to know whether a certain patient indicator will be present based on criteria that the patient meets or doesn't meet. So again, it can be used outside of healthcare, in healthcare. It can be very complex or very simplistic, but it's a good visual to get you tracking and flowing with, what is the process. And then that may help you to find where you've got some glitches or gaps where you need to make improvement. The fishbone diagram, Ishikawa, or cause and effect. So that Ishikawa, he was one of our theorists in quality, so that name will come up again. It's a fishbone diagram, and it identifies those possibility of causes and effect or problems that can come up. This is really good to use if you're doing a brainstorming session. You may want to put different, like paper up on the wall, like post-it size large poster paper up on a wall, and give everyone little post-it notes, and they can put down their top 5 issues they're having or they think contributes maybe to a patient fall. And then you have them go put it on the wall or on that poster paper that's on the wall, and you kind of start seeing a pattern of some different categories as people brainstorm with ideas of what do they think is causing the falls. So you might see we're short-staffed, the patients aren't using the call light, the floor is wet after it's cleaned from housekeeping. You can really let your imagination go wild. But when you then start drilling down, you can come up with some possible problems or causes, and then that can help you to keep drilling down to find it, where do you have issues. This is also a really good tool if you feel like you're just hitting a brick wall. You're falling into a rut. You don't know where to go to create change or to have a positive outcome. You can also use this tool, and it can help you overcome some of those barriers by, again, a visual. So here's an example. They call it a fishbone also because the head of a fish is to the far right where it says missed free throws. Kind of imagine that as the head of the fish, and then the different skeleton with the information laid into the diagram is actually then that skeleton of the fish. So that's actually how they came up with the fishbone diagram, because of the visual, how it appears. But cause and effect, we're looking at, in this case, the end effect, missed free throws. So what they're trying to look at, what is the cause? So you've got some main headers in the rectangle areas. So you got people, who are the shooters, material, which is a ball, method, which is their shooting mechanism, a machine, which is hoop and backboard, and then the environment of weather. So then you have all these other arrows that feed into the central arrow in the middle of the page that flows to where it says missed free throws. So this is showing all these different areas that feed into why is there the effect of a missed free throw. So you can look at this, and you may want to really concentrate, if you're in a healthcare situation, one of the categories, and then come up with action plans. But again, it helps get you visually centered. It helps, again, with brainstorming, collecting a lot of data points and putting it in one visual so that everyone can look at it and discuss it, whether you pick it apart, readapt it maybe at future meetings that you're having to work on a project. But this is a really good stepping stone to get a lot of information in one quick visual. Checklist. You can never underestimate the power of a checklist. This one is from the World Health Organization, and it's a surgical safety checklist, and this is universally utilized. Don't get too caught up that you can't read it very well from this slide, but it is available on the internet. You can Google and find this information. But the main thing I want you to take away is just the checklist. It's not cookbook medicine. I know that pilots, every time they're going into the cockpit and going to be flying a plane, they use checklists, and it helps keep you grounded. It helps to make sure you are not having any human error. You're not forgetting any key steps. You have all critical things in place and you've checked them all through. We're not depending on our memory. We have it down in a checklist. So this is just one example. There are many that are out there. I'm sure your organizations have quite a few as well, but the checklist is a very critical tool that we use in healthcare. Control charts, these are very engaged with the statistical process control, or SPC. It is looking at a graph, it's looking at a process over time, there's data plots, and they actually, in the world of stats, I think they like to see 20 to 24 minimum data points that you're looking at. So they really want to see data spread out over time to really get a true value of that process, and is it statistically sound, which direction is it going. You do have an average, which we'll look at an example, but with the statistics, you have an upper control limit, you have a lower control limit, and those are both keyed off of what your average is. And it's based, again, from historical data. You may, within this process of a control chart, as you move down the road, months, years down in this process, you may need to reestablish a new control limit because your average may change because you've made improvements by performance improvement, process improvement, quality initiative. So you have to keep that in mind. Another thing that's good to keep in mind with a control chart, you can also go in there and you can add little bubbles or text box and put like different action steps you've taken. So you may see a real change in your data at some point, and maybe it's because you added a new process. So you want to make sure you recognize that on the graph so that visually you know, okay, what happened that all of a sudden we're doing so much better. And that's going to help you to remember, A, that you took that action step and it correlated at what time over history on that data, or on that chart rather. This is an example, and so you can see that where it says UCL, it's got a 3 sigma by it. So usually they're looking at the upper control limit being set from the average as being 3 deviations from the average, 3 standard deviation. And then the lower control limit, excuse me, which is more towards the bottom of this slide, it is showing a 3 standard deviation below the average. So you've got this range, and then you're looking to see, are your plots, are they falling within that range? If you see all the plots falling within the range, you usually consider that a controlled situation. If you start seeing a lot of trends going downward all in a row, then you may have a situation that there's a change. You may have some kind of special cause effect going on that you need to really review. Same if you have all the plots going in an upper direction instead of this zigzag back and forth. Another situation is if you have a plot that falls either above your upper control limit or below your lower control limit. You may have an issue. You may have a special, cause effect issue. You may have something you need to investigate, but for the most part, it's going to be pretty steady with the up and down zigzag. Again, that's a very, very brief overview. This is, again, very embedded with statistics. Gives you a lot of information. Visually helps you to stay on track with what you are focusing upon. The histograms, they are looking at plots, and they're looking at a distribution of a shape. So you're going to see these bars of data flowing across your bottom X diagram, the Y diagram being or the Y axis being over to the frequency, the age being the X axis. And you're just looking at a normal distribution. You're just looking to see, okay, how many, the frequency for this, evaluation tool, the age category. So it's just a piece of information, and you're just looking to see, okay, how did the data fall? On the other hand, a Pareto chart is another bar graph, but it's going to actually take you looking at the longest bar being to the far left, so right by the y-axis, and then you're going to be visually looking at the areas, the bars to the far left are going to be the ones that are going to have the biggest bang for your buck. If you really have to drill down to find out where your significant issues are, your situations, it's going to really pop just by how the bar graph flows. So what I mean, you can see in this Pareto chart, customer complaints. So the y-axis over to the far left, you're looking at the number of complaints. Okay, so that's a volume. Then you're looking at the bottom, which is the x-axis, and you can see how they've split them out by these bar graphs. You can see over to the far left where it says parking difficult. That is one of the key issues. That's the main driver of where they got customer complaints. So if I was looking at this and I really wanted to focus in on where I could make the biggest impact, I'm going to go to the far left bars and see that parking, that's a big one. Sales representative was rude, poor lighting, layout confusing. Those are some of the bigger drivers. So you want to really focus on those. And then the other areas that are maybe less significant, such as the sizes were limited, clothing faded, clothing it shrank when they washed it. Those are not as significant. So it kind of is following that 80-20 where in this situation, that top 20% is where you're really wanting to put the most focus on in this category to be impactful. So again, just kind of looking at that to make an impact on improving customer satisfaction. The scatter plot, this is showing a couple of data points, and they're in relationship to a line. So you're trying to see, is there a relationship to where you plot these points out and to that line or that issue. So this one we're looking at Old Faithful. Okay, in Yellowstone National Park. So they're looking over on the y-axis, the timing between the eruptions, and then they're looking at how long did the eruptions last. So they're trying to see, is there a correlation between the two. So that's what they're looking at. So if you start seeing the little dots, the plots on the scatter diagram all really land exactly on your line, it may show a very high correlation, that you have proven that there is a high correlation, or maybe not. So it just is another way of looking at the information. Also, I should say that so many of these information with the graphs, you can plot these through Excel. Sometimes there's other software you can use, but there's tools out there. You just have to play with them and get used to using them so that you can do your graphs. So this is showing raw data. So again, if I was wanting to look just step one, I'm collecting data and I'm doing it on temperature and ice cream sales. Is there a correlation? Bingo. Here we go. We look at a scatter diagram. This was just another way of looking at that same information we just saw. That was just data in a just raw data. So this is taking that raw data, putting it into the scatter plot to see if there is a correlation. So again, it gives you another visual way to look at the information to see, is there a correspondence with the temperature and your sales with your ice cream? The radar chart, or they also call it a spider diagram or a spider chart, It looks like a starburst. It looks like a star chart, as another name for it. It just is displayed a little bit different. You may see some overlapping. This one they're using for a garden center, and they're looking at all the different months and their value points to the right. Their indicators. They're looking at bulbs. They're looking at seeds, flowers, trees, and scrubs. Or yeah, the shrubbery, I guess is what I want to say. So they're trying to see, is there times of the year where they have peaks in this? So, they may want to use this for their inventory, for their staffing, those kind of factors that would play into the world of a garden center. So it just gives you a way to look at multiple data points just all in one graph. Again, there can be that overlapping, but again, it's a nice visual to what you're wanting to look at. Okay, this is looking at a spider diagram, or excuse me, a spaghetti diagram. This is showing the pathway. You're looking at what is going on with traffic. You're looking at the flow. So you want to see, are there a lot of redundancy? This would be a great tool to use in Lean Six Sigma, especially when you're wanting to look at decreasing extra steps and having a lean organization. I'm looking at this, I'm thinking all these numbers, maybe it corresponds to a patient room. And if I start seeing staff and maybe the staff, maybe want the nurses in black on this diagram, another staff member, maybe an aide is in the blue, and then maybe the kind of the orange color, I don't know, maybe that's a secretary. But I may look at this and decide, when I look at this and I plot the steps that the staff are taking, I may need to make adjustments. I may need to make there to be a quicker access for the staff to get supplies. So I may want to move supplies closer to where their patient load is or their patient rooms are. Because if I'm looking at this and I want to save steps, save time, and also be a satisfier for the staff, but maybe also for the patient, this will give you a good visual just to see, where do I have, steps that could be improved. If you're doing your Gemba walk, so you're out there and you're actually going to the front lines, this would be something that you could, do a quick drawing on a pad of paper and just kind of get a feel for, how many times am I visually standing outside of room number one, and am I looking at the nurse going back and forth, and I'm just tracing that on the paper. So it looks a little messy. It's not a really clean diagram compared to some of the others, but it can add value and it can give you a good direction to go. The swim lane is a tool, and again, they're looking at tasks, they're looking at process. It's a flow chart also. So they're wanting to look at various steps and they're putting those into lanes. So they're wanting to see, with the labeling, how are things flowing. It corresponds to a team, corresponds to individual. So this one you can see they kind of have the rows, and then they also have the columns. So they're looking across these rows at customer knowledge, provider knowledge, if there's explicit knowledge, provider processes, support processes. And then they're looking at the top, the phases, which are in the headers at the columns, for discovery, define, develop, deliver. I have to say this is not a tool I have used a lot. We did discuss it when I was doing my Lean Six Sigma black belt training. So it's good to know. And again, there may be certain points in time where you may decide, yeah, this might be helpful. I just have to say this isn't a tool I gravitate to a lot. So just take that for what it's worth. But I wanted you to be aware of it. So software. This is not all-inclusive. This is just a few examples. Minitab, they use this a lot with the statistical component with the Lean Six Sigma drill down. It's a little bit more costly, so you really have to get some capital money to buy this software. What I use is in Excel, you can add another package onto your Excel called QI macros. kind of the same format as Minitab, maybe not as many bells and whistles, but for what I need, it works fine. And it does the same thing with the statistical components for a Lean Six Sigma drill down. Crimson, this is software that it's a national software that people can purchase. It's expensive, so HCA is bought into using Crimson. But it gives us a lot of data about healthcare facility information, about readmissions, about costs for pharmaceutical use, um, physician specific information. So we do use the Crimson data for our ongoing practitioner evaluations or their quality files. It is a really good tool. It has a broad spectrum of who you can compare it to nationally, or just within, maybe for us, HCA, or even down just to our division. So you can slice and dice who you want to compare yourselves to in many different directions to see if you have best practices even across the nation when you compare your data. It can also help you hone in on where do you have opportunities. So maybe we want to look at our readmissions and we want to see how we look even just with our joint replacement readmissions. This is a tool that can help us to get down to that level. Cactus, it's another HCA product. And it is looking at medical staff credentialing. So again, I know there's other tools out there, but it's a repository of information. So we're getting all the different requirements we have to have for medical staff credentialing, and it's all in one package. It's all in one software. Comet. This is an HCA tool that we use for core measure abstraction. So it's a great tool. HCA, I have to say, has done an outstanding job with collecting this information. It has embedded in the software the help screens, the specifications from CMS and from Joint Commission. It highlights quarter to quarter when there's changes that have occurred from the previous quarter, so it really draws your attention to where there's specification changes. So you really know when you're doing an abstraction, you really have to evaluate, am I working from the most current specifications for that quarter? Choice, it's another HCA product, and it is looking at mortality and complications. It is risk adjusted, so again, it helps us to look apples to apples. For the complications, was that an expected outcome or not? Mortality, was that expected or not? Do they have a lot of comorbidities or coexisting problems in their health that maybe made them more likely to pass away or to have a complication? These are just a few. There is an extensive amount of software out there. So again, you might want to check with your facility to see what they're using, but this just gives you a little bit of ideas of some things that I know that we use. Last slide. Risk-adjusted data. I just again wanted to mention that there's a methodology. It's usually embedded in whatever software you're using. I mentioned that choice software where we are looking at morbidity, mortality, comorbidities, and complications. And it is risk adjusted. So, you want to look at those risk factors, those comorbidities. You want to look at patient's age. You want to look at all these factors. But when all is said and done, you need to have a fair way to compare your information, apples to apples, with other organizations. So that's why they have this risk-adjusted methodology built into the software. A lot of it's coding driven, so again, your coders get to be your best friends with really fully capturing what the physician has documented in their charting, in their dictations. So based on that, it drives the coding. Based on the coding, it drives that the patient has a higher DRG weighted experience, and again, it helps you to look at that apples to apples. So just a really quick example. Let's say we're looking at a patient who passed away. They're 96 years old. They have end-stage lung cancer. They have heart failure. They're an atrial fibrillation patient, and they have pneumonia. Looking at that pneumonia death is much, much different than looking at a mortality cause of a patient who's maybe only 36 years old, don't have any comorbidities, and then they die from pneumonia. We're not comparing apples to apples with those two patients, so we have to really take that into consideration. Those comorbidities that 96-year-old patient has. We also need to, again, on the other hand, look at this 36-year-old. That's a very young age. So what really happened with that patient that caused them to have a mortality? So two different ends of the spectrum, two different comparisons, but again, it kind of helps you to know apples to apples, why you need that risk adjusted methodology, and again, to stay high on alert when you have something that doesn't feel right in your gut, like that 36-year-old who died of pneumonia. What else was going on? Was that expected based on the condition at that moment in time when they presented? Was there something else that happened? So again, you need to evaluate that.